Hello, welcome to Stats with Warnke. Today we're going to be covering two variable statistics, and we're going to be getting into scatter plots, and this episode is going to be about the vocabulary associated with that section. So the first part of Chapter 3 is going to revolve around, well, I guess all of Chapter 3 is going to revolve around two variables, and the two that we're going to be discussing are an explanatory and a response variable. So the response variable is what we are measuring in the study or what we are trying to predict from another variable. So our explanatory variable is the one that we think may explain or influence the changes. So a lot of times that's going to be what we are directly manipulating, and then we're looking for changes in the response variable. When we are displaying those two variables, we make a scatter plot. So a scatter plot is going to have an x and a y-axis, and it's going to show the relationship between two quantitative variables. That's the key, is that this is about two quantitative variables, so things that we can find the average of, that we can take measurements on, things like that. One variable is going to appear on the horizontal axis. The other variable is going to appear on the vertical axis. We always put the explanatory variable on the x-axis. So that's our first step. When you are deciding which variable goes on which axis, put the explanatory on the x-axis. And then our response variable, the one that we are looking for prediction in or changes in, that's going to go on our y-axis. As with every graph that we make, remember to include a label and a scale or a legend if appropriate. And then lastly, plot those individual values. So our scatter plots will look something like these. Just a couple little dots with an X and a Y. I don't have these labeled because there's no real interpretation for these. I just wanted a reference for what these would look like. When we are talking about what the scatter plot shows us, one of the key features is it like a positive association or a negative association? You can think of these like slopes. So does it have a positive slope or a negative slope? A positive association is when large or above average values of one variable correspond to large or above average values in the other variable. A negative association is when there's like that inverse relationship. When large values in one variable are corresponding to small values in the other variable. Here is our acronym that we will use to describe scatter plots, and that is STUD. So those will give you the four key features that we are looking for. The first one is strength. So strength is the S in STUD. That is going to give us an idea of how close to being a line is it. So anything that's close to -1 or +1 when we look at correlation, we're not quite there yet, but anything that looks very linear, we would describe as a strong relationship or strong association. Anything that is close to random scatter, so just kind of like a cloud of data points, that's what we are going to look at and call that a weak or no association. So you can see the kind of this continuum. On the left-hand side, we have -1. On the right-hand side, we have +1. And you can go from strong to moderate to weak. In the middle with 0, that would be no association. And then we go back up from weak to moderate and to strong as we go from those positive to negative associations. So that's our first one in STUD is the S. The T stands for the type. So we have two general classifications that we're going to use, and that is linear and nonlinear. So linear is when a pattern of a scatter plot, represented here in the red points, generally appears to have that constant increase in our values, whereas in the blue you see that non-constant rate of change in our values. So linear or nonlinear. As we look at the scatter plot, we'll just kind of estimate it to the best of our abilities. One that we're going to develop more in section 3.2 is unusual features or unusual points. For right now, you can just kind of classify this as outliers or gaps. Those are the two types of things. We have a few different other definitions that we use. So outliers has a very particular definition. High leverage points and influential points are also very particular definitions. So when we get more into section 3.2, we'll get into those very specific ones. But for right now, we'll look for unusual features. Any points that kind of don't fit with the trend, or if we notice any gaps, any clusters in our data. And then the D. So we have S is our strength, T is our type, U is unusual features, and the D in stud is it positive or negative? So here we have on the left-hand side a positive association. On the x-axis we have the number of points scored in a game, and then on the y-axis we have wins. So you can see that generally speaking, as x increases, as you score more points, you tend to win more games. And then also on that right-hand side, you can see that we have the percent taking the SAT in a particular school on the x-axis, and then the y-axis is the mean math score. So generally, as it tends to more and more students in a particular school taking the SAT, you get lower average scores. So that's the vocabulary that you will need for this section in section 3.1.